Hey everyone, welcome back to the channel. Today, we're diving into the world of advanced electronics with 10 mind-blowing projects that you can actually build yourself. That's right, we're talking autonomous robots, smart homes straight out of a sci-fi movie, and even getting our hands dirty with the power of the sun. Whether you're a seasoned engineer or just starting out, there's something here to spark your imagination and get you excited about the possibilities of technology. So grab your soldering iron, fire up your 3D printer, and let's get building. All right, let's kick things off with the coolest project on the list. Building your very own autonomous robot. I'm talking about a machine that can sense its environment, make decisions, and navigate around obstacles all by itself. No remote controls, no joystick, just pure robotic intelligence. Now, before you start picturing a Terminator-style uprising, let's be clear, we're building something awesome, not apocalyptic. This project is all about combining sensors, motors, and some clever programming to create a robot that can react to its surroundings. Think about a robot that can follow you around like a loyal pet, only it doesn't need to be walked or fed. Or maybe you want to build a robot that can navigate a maze or even solve a Rubik's Cube. The possibilities are pretty much endless, limited only by your imagination and maybe your coding skills, but hey, that's what online tutorials are for. We'll start by talking about the different types of sensors you can use to give your robot senses. We're talking ultrasonic sensors for measuring distance, infrared sensors for detecting objects, and maybe even a camera, so your robot can see the world around it. Then, we'll dive into the world of microcontrollers, the brains of our operation, and learn how to program them to control the motors that will make our robot move. Don't worry if you're not a coding wizard. There are tons of resources and pre-built libraries available to get you started. We'll walk through the basics of robot movement, like how to make it move forward, backward, and turn. Then we'll step it up a notch and learn how to use sensor data to make our robot react to obstacles and navigate autonomously. And the best part, building an autonomous robot isn't just about the finished product. It's about the journey, the problem solving, the aha moments when your code finally clicks and your robot springs to life. It's about learning by doing, experimenting, and pushing the boundaries of what you thought was possible. All right, who's ready to turn their humble abode into a futuristic smart home? I'm talking about the kind of place where the lights turn on when you walk in the room, the temperature is always perfect, and your coffee maker greets you with a fresh pot every morning, and the best part, we're going to build it all ourselves. This chapter is all about taking control of your living space using the power of electronics. We'll be diving into the world of Internet of Things, IoT, where everyday objects are connected to the internet, allowing you to control them with your smartphone or even your voice. Imagine dimming the lights, adjusting the thermostat, or even locking your front door, all without leaving the comfort of your couch. Sounds pretty awesome, right? We'll start by exploring different smart home platforms and protocols like Zigbee, Z-Wave, and Wi-Fi. These are the languages that our devices will use to talk to each other and to the internet. Don't worry, it's not as complicated as it sounds. We'll break it down in a way that's easy to understand, even if you're new to this whole smart home thing. Then we'll get our hands dirty with some actual projects. We'll learn how to control lights using relays, build our own smart thermostat using temperature sensors, and even create a security system that alerts you to any suspicious activity. And the best part is, you can customize these projects to fit your own needs and preferences. Want to build a system that automatically waters your plants when the soil gets dry? No problem. How about a smart mirror that displays the weather forecast and your upcoming appointments? We can do that too. The possibilities are limited only by your imagination and maybe your budget, but we'll try to keep things affordable. So get ready to upgrade your home and your life with the magic of smart home automation. Trust me, once you start automating things, you'll wonder how you ever lived without it. Get ready to step into the world of artificial intelligence, because in this chapter, we're teaching machines to see. That's right, we're diving into the fascinating world of image recognition, where computers can analyze and understand images just like we do. We'll be using machine learning algorithms, the same technology that powers self-driving cars and facial recognition software, to build our own image recognition systems. Now, before you get any ideas about building your own Skynet, let's start with the basics. We'll learn about different types of image recognition tasks, like object detection, image classification, and facial recognition. We'll explore popular machine learning frameworks like TensorFlow and PyTorch, which provide the tools we need to train our own image recognition models. Don't worry if you're not a machine learning expert yet. We'll break down the process step by step and provide you with all the resources you need to get started. We'll even walk through a few fun projects, like building a system that can recognize different types of flowers, identify different breeds of dogs, or even tell you if you're holding your phone upside down. The really cool part about image recognition is that it opens up a whole new world of possibilities for interacting with the world around us. Imagine building a robot that can recognize different objects and pick them up, or a security system that can identify unauthorized personnel. This technology has the potential to revolutionize everything from healthcare to transportation, and we're just scratching the surface of what's possible. So get ready to unleash your inner tech wizard and join me as we explore the exciting world of image recognition. Chapter 4. Reaching for the stars, building your own satellite communication system. Buckle up, because we're about to launch ourselves into the final frontier space. Okay, maybe not literally, but in this chapter, we're going to build our very own satellite communication system. That's right, we are talking about sending and receiving signals from satellites orbiting hundreds of miles above the Earth. Now, before you start building a giant satellite dish in your backyard, let's clarify a few things. We won't be launching our own satellite into orbit, although that would be incredibly cool. Instead, we'll be using existing satellite networks to send and receive data. We'll start by exploring the basics of satellite communication, like how satellites work, what kind of frequencies they use, and how to track them in the sky. Then we'll dive into the hardware side of things and learn how to build our own ground station, complete with an antenna, receiver, and transceiver. Don't worry, building a ground station is more attainable than it sounds. We'll explore different antenna designs, from simple handheld antennas to more powerful directional antennas, and discuss the trade-offs of each. We'll also learn how to use software-defined radios, SDRs, to receive and decode satellite signals. Once we have our ground station up and running, we'll get to the really fun part. Sending and receiving data. We'll explore different satellite communication protocols and learn how to send text messages, images, and even sensor data through space. Imagine tracking the International Space Station as it flies overhead and decoding the telemetry data it transmits. Or how about receiving weather images directly from a meteorological satellite? The possibilities are literally out of this world. Chapter 5. Harnessing the Power of the Sun. Building a solar power inverter. Get ready to go green and save some green, because in this chapter, we're harnessing the power of the sun to generate our own electricity. That's right, we're building a solar power inverter, the heart of any solar energy system. This device takes the direct current DC power generated by solar panels and converts it into alternating current AC power that can be used in our homes and businesses. Now, you might be thinking building an inverter sounds complicated. And you know what? You're not wrong. It does involve some serious electronics, but don't worry. We're going to break it down step by step, making it accessible to anyone with a passion for renewable energy and a willingness to learn. We'll start by understanding the basics of solar power, how solar panels work, and why we need an inverter in the first place. We'll then dive into the different types of inverters, including string inverters, micro-inverters, and battery-based inverters, discussing the pros and cons of each. Once we've covered the theory, we'll roll up our sleeves and get building. We'll explore different inverter designs, from simple modified sine wave inverters to more complex pure sine wave inverters, which are essential for powering sensitive electronics. We'll learn about the components that make up an inverter, including transformers, capacitors, transistors, and microcontrollers, and how they all work together to convert DC power to AC power. We'll also discuss safety precautions when working with high voltage and current, because safety always comes first. Building a solar power inverter is not just about saving money on your electricity bill, it's about taking a step towards a more sustainable future. It's about reducing our reliance on fossil fuels and embracing clean, renewable energy sources. Chapter 6. Entering the third dimension. Building your own 3D printer. Get ready to enter the world of additive manufacturing, because in this chapter, we're building our very own 3D printer. That's right, we're talking about taking digital designs and transforming them into real-world objects, layer by layer. This technology has revolutionized prototyping and manufacturing, and now you can have that power right on your workbench. You might think that building a 3D printer is something out of a science fiction movie, but trust me, it's more achievable than you might think. We'll be diving into the world of fused filament fabrication, FFF, the most common type of 3D printing, where a plastic filament is heated and extruded through a nozzle, building up an object layer by layer. We'll start by understanding the different parts of a 3D printer, from the extruder that melts the filament to the stepper motors that precisely control the movement of the print head. We'll explore different 3D printer designs like Cartesian, Delta, and Core XY, discussing the advantages and disadvantages of each. Then we'll get our hands dirty assembling our printer. Don't worry, we won't be left staring at a pile of parts. We'll walk you through each step of the process, providing clear instructions and helpful tips along the way. We'll learn how to calibrate the printer, load the filament, and send our first print job. But building a 3D printer is just the beginning. Once your printer is up and running, the possibilities are endless. You can design and print your own custom tools, create replacement parts for broken appliances, or even print out your own toys and gadgets. Chapter 7. The Power of Many Designing a Swarm Robotics System. Get ready to witness the power of collective intelligence, because in this chapter we're diving into the fascinating world of swarm robotics. That's right. We're not just building one robot, we're building a whole swarm of them. This is where individual robots, each with their own simple set of rules, interact and cooperate to achieve a common goal, just like ants in a colony or bees in a hive. Now, you might be thinking, why build a swarm of robots when I can just build one really complex one? Well, that's where things get interesting. Swarm robotics offers some unique advantages. For example, a swarm of robots is inherently more robust. If one robot fails, the others can compensate. They're also highly adaptable to changing environments and can perform tasks that would be impossible for a single robot to accomplish alone. Think about tasks like search and rescue operations in disaster areas, environmental monitoring over large areas, or even exploring other planets. We'll start by exploring the principles of swarm intelligence, how simple rules can lead to complex emergent behavior. We'll then delve into the different types of swarm robotics architectures, including centralized, decentralized, and hybrid systems. Then we'll get our hands dirty designing and building our own swarm of robots. We'll explore different communication methods like infrared, radio frequency, or even visual cues. We'll learn how to program our robots to interact with each other, avoid collisions, and work together to achieve a common goal. Chapter 8. Building the City of the Future, Smart City Infrastructure. Get ready to upgrade our cities to the next level, because in this chapter, we're diving into the world of smart city infrastructure. We're talking about using technology to improve the efficiency, sustainability, and quality of life in our urban environments. Think about cities that can monitor and manage traffic flow in real time, optimize energy consumption, and provide citizens with personalized services. Now you might be thinking, this sounds like something out of a futuristic movie, and you know what, it kind of is. But the future is closer than you think. Smart city initiatives are already being implemented in cities around the world, and we're going to explore the technology that makes it all possible. We'll start by understanding the different aspects of smart city infrastructure, from smart grids that manage energy distribution to intelligent transportation systems that optimize traffic flow. We'll explore the use of sensors, data analytics, and cloud computing to gather and analyze data from various sources. Then we'll dive into some hands-on projects that demonstrate the principles of smart city infrastructure. We'll learn how to build a traffic monitoring system using computer vision, design a smart lighting system that adjusts brightness based on ambient light levels, and even explore the concept of smart waste management using sensors to optimize garbage collection routes. Chapter 9. Unlocking the Power of Deep Learning. Get ready to unlock the true potential of artificial intelligence, because in this chapter, we're diving deep into the world of deep learning. We're talking about building artificial neural networks inspired by the structure of the human brain that can learn and make decisions from vast amounts of data. This is the technology behind breakthroughs in natural language processing, image recognition, and even self-driving cars. Now, you might be thinking deep learning sounds incredibly complex, and you know what? You're not wrong. It does involve some advanced mathematics and computer science concepts, but don't let that intimidate you. We're going to break down the fundamental concepts in a way that's easy to understand, even if you're new to the world of machine learning. We'll start by exploring the basics of artificial neural networks, how they work, and the different types of layers that make up a deep learning model. We'll then dive into popular deep learning frameworks like TensorFlow and PyTorch, which provide the tools we need to build and train our own models. But this chapter isn't just about theory. We'll get our hands dirty with some exciting projects that demonstrate the power of deep learning. We'll learn how to build a chatbot that can understand and respond to natural language, create a music generator that can compose original melodies, or even design a game-playing AI that can learn and improve its strategy over time. Chapter 10. Riding the Wave of the Future, 5G Communication. Hold on tight, because we're about to ride the wave of the future. 5G communication. This isn't just an incremental upgrade, it's a revolutionary leap forward in wireless technology, promising lightning-fast speeds, ultra-low latency, and the ability to connect billions of devices simultaneously. This is the backbone of the future, enabling everything from self-driving cars to smart cities and immersive virtual reality experiences. Now you might be thinking, building a 5G network sounds like a massive undertaking. And you'd be right, deploying a full-fledged 5G network requires significant infrastructure and investment. But that doesn't mean we can't explore the underlying technology and even build our own small-scale 5G experiments. We'll start by demystifying 5G, understanding the key technologies that make it tick, like millimeter wave frequencies, massive MIMO antennas, and beamforming. We'll explore the different components of a 5G network, from the core network to the radio access network, and how they all work together to deliver unprecedented speed and capacity. Then we'll get our hands dirty with some exciting projects that demonstrate the capabilities of 5G. We'll explore the use of software-defined radios to transmit and receive 5G signals, experiment with beamforming to direct signals to specific devices, and even build a small-scale 5G network in our own homes or labs. Outro until next time, keep experimenting. Thanks for watching. If you enjoyed this video, don't forget to give it a thumbs up and subscribe to the channel for more awesome content. Let us know in the comments which project you're most excited to try. Remember, the future of technology is in our hands, so keep exploring, keep experimenting, and never stop pushing the boundaries of what's possible. See you next time.